Okay, so I'm going to jump over to my computer so we can calc the wind based on the notes I've given you just to make it super clear. So I think what I'll do is split the screen here. So we've got two things. So the first thing is determine the risk category, which we did, which is category 4. So that's going to dictate which map we use. The next is to determine the basic wind speed. So if I go to the next page and zoom in, this is risk category 2 wind. So I would use the category 4 table out of ASCE 7 to get this. Okay, so I wasn't sure if I had this, but I do. So if we zoom in here, and you can see the wind contours are 110 to 115 in the entirety of Utah. So you can linearly interpolate, or we can just go in there and just say it's 115, which is what I'll do here. We can also go to the ATC hazard thing, which we talked a little bit in class, and we can say we'll go into Moab, zoom in. I like to make sure that it's where I think it is, and risk category 4 is 113. So not a big difference. We can also get the seismic data like we've talked about. So I can come here. I'm going to say it's default. We want to get this from a geotech, but we'll get into that in a minute. So anyway, let's use 115. So I'm just going to keep some notes here. Okay, then we need to know the wind directionality factor. So if we come to this table, buildings for the entirety of them is 0.85. So I'm going to come here and just say KD equals 0.85. I'm not going to worry about the subscripts. The next is the exposure category. So this is where it would be important to know where our site's located. So if I come back here and I say we're building somewhere in here, this meets the definition for urban suburban areas, closely spaced obstructions that have the size of a single family dwelling. It's pretty hard to argue with that when you look at this picture and see what it looks like. Now let's say we were up here by Green River, but instead of being in town in Green River, we're building out here at a new site where there really isn't anything, then that really is going to be category C. And then if we want to go up to Salt Lake here and say we were working out at what's that crazy plant here, the mag plant here, and we're building somewhere at the mag plant, you look at the lake and the mud flats, that would qualify as category D. So let's say we're exposure B because we're surface roughness B, and you can see the definition and get into that more yourselves. So exposure category, we're just going to say B. Next is the topographic factor. So we'll go back to Moab. We'll just say that's where we're building. So zoom in here, somewhere in here. Basically, it's flat for all intents and purposes as far as KZ matters. So we're going to say KZ is 1. And since this really isn't a class about loads, or KZT is 1, that's cool if you want to choose that. I'm not expecting to make this hard. Okay, the next thing is the ground elevation factor. So this is where we are in the elevation of the world. This doesn't give me elevation, but I think Moab's around 4,000 feet, so our factor is going to be 0.86. So essentially this factor accounts for the difference in density of the air as you go up from sea level. Okay, next is the gust effect factor. So if we come here, it's 0.85 for dang near all structures that we're going to be worrying about. If you have a flexible structure, then things get a little more complicated. So I need to take a slight break to have a sip of coffee here. All right, so next we get the enclosure classification. So we come to this table here. There's different definitions for different types of enclosures. So you're going to choose yours. I'm going to choose that this is an enclosed building because it's a hospital, and it is. So I'm just going to make a note of that. GCPI is plus and minus 0.18. Okay. Next, oh, sorry. Let's go to that, and then we'll say it's closed and not worry too much about writing that down. Okay, next is determine the velocity pressure coefficient, Kz or Kh. And they're the same. There's a slight nuance to it, but I always forget what it is because in practical terms, it doesn't really matter. So I've got to go back to my little elevation sketch that I did, and I'm seeing that my roof elevation is at 132 feet, and my ground elevation is at 100 feet. Makes the math easy. It's 32 feet. So I come in here. I'm exposure B. My factor is somewhere between 0.7 and 0.76. I'm just going to say it's 0.72 and skip the interpolation. You're welcome to be more precise, but at the end of the day, whether that number is 0.72, 0.71, or 0.73 probably won't matter at all. Okay, with that said, I'm ready to input into this equation. So let's do that. Our Kz factor, which comes from here, is 0.72. Kzt is 1. I like to put them all in, just keep space. I also like to, in the order of the equation, put my numbers in the same order. Then it just keeps everything nice and clean. Next is Kd, which is 0.85. I also like to put a 0 before my decimals, just to be super clear. And then the last is Ke, which is 0.86. So Ke over here we have it. And then the last is the velocity squared. So I grab my magical HP calculator. 0.0256 times 0.72 times 0.85 times 0.86. 115 squared times that gives me 17.8 pounds per square foot. And because I want to make sure I did it right, I'm going to calc it twice. I usually like to calc everything twice and check my inputs just to make sure that I did it right. So I'm going to quickly say, okay, 00256, 0.72 is Kz, 1 Kzt, Kd is 0.85 up here, 0.86 is Ke over here, 115 mile an hour wind speed. And I'm going to just do that really quick again. And hopefully you're checking it too while you're watching this to make sure I didn't make some bonehead mistake. I still get 17.819, so I'm just going to leave that at 17.8. All right, so moving on, we've got QZ and QH, which in this case we're going to call the same thing. Now we need to determine the external pressure coefficient, C sub P. So to do that, we're going to come here and we're going to say, okay, if we're the windward wall, we're 0.8, which is the pressure on this wall. If we're the leeward wall, we're somewhere between 0.3 and 0.2, depending on the aspect ratio of our building, so the length to the width. So I'm going to say it's closer to 2 because it is, and use negative 0.3 and positive 0.8. So CP equals 0.8 or negative 0.3. Cool. All right, next. So there's a bunch of tables, and I didn't give you all of them. That's what ASCE 7's for. And then let's calc wind pressure on each building surface. So usually, well, we'll get into that in a sec. All right, so we need our, oh, this is more involved. Anyway, so this is the equation we need. So we have Q, and QI and Q, so this is where it gets kind of funky. So Q is QZ for windward walls at the height Z above the ground. So in taller buildings, what we can do is kind of segment the wind pressure. As you go up in the building, the wind pressure gets higher. And so if we want to use a lower pressure for lower areas of the building, we can. All right, so then anyway, that's that. So there's kind of a nuance there. So let's just plug in our number. We had Q from the previous slide was 17.8. Zoom in a bit. So 17.8 times G, which the gust factor is 0.85, times C sub P, which was 0.8. Then we're going to subtract the internal pressure. So I'm going to use the same Q, and then GCPI we got earlier is plus or minus 0.18. So if you look at this, you say to yourself, oh, if I make this positive, this becomes a smaller number. The answer is a smaller number. If I make it negative, it makes it bigger. We want to maximize the wind effect, so I'm going to use 0.18 in the negative, and then solve for that. All right, so 17.8 times 0.85 times 0.8, and then 17.8 times 0.18, and then I'm going to add those together, so I get 15.3 pounds per square foot. Okay, so that gives me the pressure on one side of the building. Now, if I want the pressure on this other side, I'm going to recalc that using a CP factor of 0.3. So let's just do that really quick. I'll just copy this down, and instead of the 0.8 here, I'm going to have 0.3, and it's negative. So now I'm going to use a positive CPI factor right here and calculate that. So let's do this. 17.8 times 0.85 times 0.3 now. 17.8 times 0.18 times, essentially take the, that's not right, take the absolute value. So now I have, on one side of my building, I have 15 pounds a square pushing here, 7 some odd change pulling here. And so if I want to find the net wind pressure on my structure, I could add those two together, or P total, I guess. Let me do little p. So it's going to be 15.3 plus 7.75, and that's still in my calculator, so that's 23.05 pounds per foot squared. So when the new code came out for wind, which was like 10 times more complicated than it used to, this old dude I worked with said, you know, you can either say wind pressure is around 20 pounds a square foot, or you can calculate it for 2 hours and realize it's still around 20 pounds a square foot. So not much changed. All right, that's wind. So what we would do now in our building is we could apply that total pressure of 23 pounds a square to one side of the building, and then we can work out how that wind pressure gets to the shear walls. That's essentially what we'll be doing. All right, we're going to start a new one for seismic here in a sec.